Welcome to this comprehensive video on solving literal equations, also known as rearranging formulas. I'm excited to guide you through this essential algebraic skill that will serve you well in mathematics and science. A literal equation is simply an equation that contains multiple variables. Unlike regular equations where we solve for a number, literal equations let us express one variable in terms of the others. Notice how each formula contains multiple variables, like length and width in the area formula, or mass and acceleration in Newton's law. These are all literal equations. Mastering literal equations is crucial for success in higher-level mathematics and sciences. They appear everywhere, from basic algebra to advanced physics. Our goal is to learn how to isolate any variable we need, expressing it in terms of the others. Get ready to master the art of rearranging formulas. In the next sections, we'll dive deep into the step-by-step process and work through detailed examples together. Now that we've introduced literal equations, let's dive into the fundamental concepts that will help you master this important algebraic skill. First, let's clearly define what literal equations are. A literal equation is simply an equation that contains more than one variable. These equations are everywhere in mathematics and science. Here are some common examples you've probably seen before: the area of a rectangle, the circumference of a circle, and the simple interest formula. Notice how each equation has multiple variables. In the area formula, we have a, l, and w. In the circumference formula, we have c and r. In the interest formula, we have I, p, r, and t. Multiple variables make these literal equations. When we solve literal equations, our goal is to isolate one specific variable on one side of the equation. This means we want to get that variable by itself. For example, if we start with the area formula and want to solve for w, we need to isolate w on one side. The result is w equals a divided by l. Notice how w is now isolated on the left side, expressed in terms of the other variables. To isolate variables, we use inverse operations. These are operations that undo each other, like addition and subtraction, or multiplication and division. Addition and subtraction are inverse operations. If we add 3 to 5 to get 8, we can subtract 3 from 8 to get back to 5. Similarly, multiplication and division are inverses. The most important principle in solving equations is maintaining balance. Whatever operation you perform on one side of the equation, you must perform the same operation on the other side. Think of an equation like a balanced scale. If we have x plus 3 equals 7, both sides are balanced. To isolate x, we subtract 3 from both sides. This maintains the balance while getting x by itself. Let's summarize the key concepts we've covered. Literal equations contain multiple variables. Our goal is to isolate one variable. We use inverse operations to undo operations affecting our target variable, and we always maintain balance by doing the same thing to both sides. These fundamental concepts form the foundation for solving any literal equation. In the next section, we'll see exactly how to apply these principles step by step. Now that we understand what literal equations are, let's learn the systematic approach to solving them. There are 4 essential steps that will guide you through any literal equation problem. Here's our 4-step framework. Step 1, identify the variable you want to isolate. Step 2, apply inverse operations. Step 3, continue until the variable is isolated. Step 4, simplify your result. Let's demonstrate this process using the area formula for a circle. Suppose we want to solve for the radius r in terms of the area A. Now let's walk through each step in detail, showing you exactly what to think and do at each stage. Step 1 is to clearly identify which variable you want to isolate. In our equation a equals pi r squared, we want to solve for r. This means r should end up by itself on one side of the equation. Step 2 involves applying inverse operations. Look at what operations are being performed on your target variable, then undo them using inverse operations. To undo these operations, we need to work backwards. First, divide both sides by pi to undo the multiplication. Then take the square root of both sides to undo the squaring. Step 3 is to continue applying inverse operations until your target variable is completely isolated. In our case, r is now by itself, so we've successfully isolated it. Step 4 is to simplify your result if possible. Check if you can combine like terms, reduce fractions, or make the expression cleaner. In this case, our answer is already in its simplest form. Remember, this systematic approach works for any literal equation. Identify your target variable, apply inverse operations to undo what's being done to it, continue until it's isolated, and then simplify. This methodical process will help you solve even the most complex literal equations with confidence. Now we'll work through our first example using a formula you've probably encountered before: the temperature conversion between Celsius and Fahrenheit. Here's our starting formula. C equals 5/9 times the quantity F minus 32. This formula converts Fahrenheit temperatures to Celsius. Our goal is to rearrange this formula to solve for F. We want F by itself on one side of the equation, expressed in terms of C. First, let's identify what operations are being performed on F. F is being subtracted by 32, and then that result is multiplied by 5/9. To isolate F, we need to undo these operations in reverse order. First, we'll eliminate the fraction by multiplying both sides by 9/5. We multiply both sides by 9/5. This is the inverse operation of multiplying by 5/9. After multiplying both sides by 9/5, the fractions cancel on the right side, giving us 9/5 C equals F minus 32. Now we need to isolate F completely by adding 32 to both sides. This eliminates the negative 32 on the right side. We add 32 to both sides of the equation. Our final answer is F equals 9/5 C plus 32. We have successfully solved for F in terms of C. Let's verify our answer makes sense. If C equals 0 degrees, then F equals 9/5 times 0 plus 32, which equals 32 degrees Fahrenheit. This is correct. 0 degrees Celsius is indeed 32 degrees Fahrenheit. The key insight here is that we used inverse operations in reverse order. Since F was first subtracted by 32, then multiplied by 5/9, we reversed this by first multiplying by 9/5, then adding 32. Now let's work through our second example. We have the area formula for a triangle. A equals 1/2 times base times height. Our goal is to solve this literal equation for h, the height of the triangle. Looking at our formula, we can see that h is currently being multiplied by both 1/2 and b. To isolate h, we need to undo these operations using inverse operations, working step by step. Step 1. We need to eliminate the fraction 1/2. To do this, we multiply both sides of the equation by 2. Remember, whatever we do to one side, we must do to the other side to maintain equality. Notice how the 2 and 1/2 cancel out, leaving us with 2a equals bh. This is because 2 times 1/2 equals 1, which doesn't change the value of bh. Step 2. Now we need to isolate h completely. Since h is being multiplied by b, we divide both sides by b. This will leave h by itself on the right side of the equation. Perfect. We've successfully isolated h. The b in the numerator and denominator cancel out on the right side, leaving us with h equals 2a divided by b. This is our final answer. Let's verify our answer makes sense. If we know the area and base of a triangle, we can now calculate the height using our formula h equals 2a divided by b. This formula tells us that height is proportional to area and inversely proportional to the base. This completes our second example of solving literal equations. We successfully transformed the area formula to solve for height by using inverse operations, multiplying by 2 to eliminate the fraction, then dividing by b to isolate h. The key is to work systematically, one operation at a time. Now that we've worked through some examples, it's crucial to understand the most common mistakes students make when solving literal equations. By recognizing these pitfalls, you can avoid them and solve equations more confidently. The first common mistake is not correctly identifying inverse operations. Let's look at the area formula for a circle. If we want to solve for r, we need to understand what operations are being performed on r. Here's what often goes wrong. Students see pi times r squared and think they should subtract pi, but multiplication and addition are different operations. Since r is being multiplied by pi, we need to divide by pi to isolate r squared. The second major mistake is forgetting to apply operations to both sides of the equation. This breaks the fundamental rule of algebra that whatever you do to one side, you must do to the other. Here's the mistake in action. A student might subtract 2l from the right side only, thinking they're isolating the term with w. but this creates an unbalanced equation. We must subtract 2L from both sides to maintain equality. The third common mistake involves order of operations. Students sometimes get confused about which operation to undo first when multiple operations are applied to the variable. In this triangle area formula, b is multiplied by both 1/2 and h. The wrong approach divides by h first, making the algebra Messier. The correct approach multiplies by 2 first to eliminate the fraction, then divides by h. The fourth common mistake is making sign errors when moving terms across the equal sign. This happens when students forget that moving a term changes its sign. In this slope-intercept form, to isolate mx, we need to subtract b from both sides. The common error is adding b instead of subtracting it, which gives the wrong final answer. To avoid these common mistakes, follow this checklist. First, carefully identify what operations are being performed on your target variable. Second, remember that whatever you do to one side of the equation, you must do to the other side. Follow the proper order of operations when undoing multiple operations. Fourth, pay close attention to signs when moving terms. And finally, always verify your answer by substituting it back into the original equation. By being aware of these common pitfalls and following these guidelines, you'll solve literal equations more accurately and with greater confidence. Remember, practice makes perfect, so don't be discouraged if you make these mistakes initially. They're all part of the learning process. Now that you've learned the fundamentals of solving literal equations, here are some powerful tips and tricks that will boost your success and confidence when working with these types of problems. The first and most important tip is to recognize that solving literal equations uses exactly the same principles as solving numerical equations. The only difference is that instead of working with specific numbers, you're working with variables that represent any number. Now watch how we apply the exact same steps to the literal equation. Subtract b from both sides, then divide by a. The process is identical, we're just using letters instead of numbers. Visual aids are incredibly powerful for keeping track of your target variable. Always start by circling or highlighting the variable you need to isolate. This keeps your goal clear throughout the solving process. As you work through each step, keep your target variable highlighted. This visual reminder helps you stay focused on your goal and prevents you from getting lost in the algebra. Literal equations aren't just abstract math exercises. They're the foundation of countless real-world formulas. In physics, you might need to solve for acceleration in Newton's second law. In geometry, you might solve for radius in the area formula. In finance, you might solve for time in the simple interest formula. When you understand that you're learning to manipulate the very formulas that scientists, engineers, and professionals use every day, literal equations become much more meaningful and easier to remember. Finally, here's a strategic approach to practicing literal equations that will build your confidence systematically. Start with simple formulas you already know, like distance equals rate times time. Then practice solving the same equation for different variables. Gradually work your way up to more complex formulas. Time yourself to build fluency, and always check your work by substituting your answer back into the original equation. This systematic approach will make you confident and efficient with any literal equation you encounter. Remember these 4 key strategies. Recognize that literal equations use the same principles as numerical equations. Use visual aids to keep your target variable clear. Connect your work to real-world formulas to make it meaningful, and practice strategically to build lasting confidence. With these tips, you'll master literal equations and be ready for more advanced mathematics. Congratulations! You have successfully learned how to solve literal equations, a fundamental skill that will serve you well throughout your mathematical and scientific journey. Let's quickly recap the essential steps you've learned. First, identify which variable you need to isolate. Second, use inverse operations to undo what's being done to that variable. Third, systematically isolate the target variable. And finally, simplify your result. This skill is essential across many fields. In physics, you'll rearrange motion and energy equations. In chemistry, you'll solve for concentrations and reaction rates. Engineers use literal equations for design calculations, and financial professionals rearrange interest and investment formulas. Remember, mastery comes through practice. The more literal equations you solve, the more confident and efficient you'll become. Challenge yourself with problems from your textbook, online resources, or real-world scenarios. If this video helped you understand literal equations, please give it a thumbs up and subscribe for more math tutorials. I'd love to hear from you in the comments. Ask questions about anything that's still unclear, or suggest topics you'd like me to cover in future videos. Your mathematical journey doesn't end here. The skills you've learned with literal equations will prepare you for systems of equations, advanced quadratic formulas, and function analysis. Each topic builds on the foundation you've established today. Happy solving, and I'll see you in the next video.